Okay, hello everyone. Thank you for joining me. Before we start, who of you knows what feature flags are? Okay, and more importantly, who knows about OpenFeature? Okay, a few, that's cool already. So cool, thank you for joining me. Before we start today, we take a look on how to not do feature flags. Who heard about the accident of Knight Capital Group back in 2012? Okay. Yeah, that was a little fun incident. Knight Capital Group was one of the biggest investment groups in America, and they misconfigured their feature flags. Actually, they lost $500 million within an hour due to the fact that they were using feature flags, and they only deployed the new feature flags to 7 out of their 8 servers. So the documentation was a little bit outdated, and they were not using a centralized feature flag management system. And the big problem was they repurposed the feature flag. So they reutilized the feature flag, which was already in the system. But we are not here to talk about war stories or things like that. I want to give you a short introduction into OpenFeature in general, and how we proceed there. Also, a lot of people already asked me if fun with flags is a little sidekick to Big Bang Theory. It is not. I will not make any kind of fun with flags jokes, but you get a nice, funny little picture of me. So, hey, I'm Simon. I'm an OpenFeature maintainer, a CNCF ambassador, and generally an open source enthusiast. If you have any questions later on or after the conference, just feel free to reach out to me. And yeah, that's basically me. For today, we have 3 bigger areas which we will be covering. First, we will normalize our view on feature flags, what they are not, how to categorize them, and things like that. Then I will give you a short introduction to OpenFeature, how the core concept looks like, and how you can interact with the OpenFeature SDK. And we will take a look at 3 pitfalls and fixes OpenFeature provides for that. So, feature flags. Generally, we define feature flags as the methodology to enable, disable, or change the behavior of features in a product or in a service during runtime. That means we are not modifying the source code. And there are multiple reasons why we want to do that. So feature flagging, a lot of people have different kind of opinions what they're used for. On the one hand, we want to coordinate and target. So for example, we want to do synchronized rollouts. So you maybe have seen this you experienced that when your company is changing their colors and logos and things like that. And everything should go live at the same time. Your press release, the change on the website, the change in the services, etc. Additionally, we want to do A/B experiments. So like exploring, for example, we have Timmy from Sweden visiting London, and suddenly he should listen instead of metal to Ed Sheeran, and we want to try to get this into our algorithm that he gets a lot of Ed Sheeran into his playlists. Or targeted releases, like enabling features for our premium users or our beta testers. And on the other side, we also want to reduce the risk with feature flags, because feature flags allow us to decouple the deployment from the release. We purposely enable a feature, and it's not like our code is now live, so the feature is live. Also, we maybe want to have a kill switch for payment providers, for example, in a web shop. So let's say PayPal is having issues, and we do not want to want their problems spoil into our systems. Or maybe we want to have this kill switch when they're getting too expensive, and we do not want to do a redeployment. And the last part is basically those progressive rollouts or canary releases, where we slowly increase basically the user base getting this new feature because we maybe do not know how our infrastructure will react to that. And based on this, we are categorizing 4 different kind of feature flags. You can read more about on Martin Fowler's blog. This is actually from Pete Hodgson's blog post about feature flag types. And the 4 categories are, on the one side, there are the release toggles, which are basically only for a short time, usually in our code base. They are not really dynamic. They are not changing that often per request. And we usually utilize this for releasing a feature slowly, maybe first QA, and afterwards everybody is getting that. Then we talked already about the ops toggles, so like our kill switches for PayPal, our third-party system, where we just want to have this little safety net of enabling and disabling that. Those are sometimes a little bit more dynamic, but usually they are in our code base for ages and years, as long as our code base normally exists. Then there's the permission toggles, which is highly dynamic. So this is like this beta testers, dog fooding, where we have, for example, where we want to enable only a certain group of people or with certain characteristics to enable these features. And those permission toggles will also be in our code base for quite a long time. And then there are the experiment toggles, which most likely will be only there for a few months, just to evaluate if we can maybe change the conversion rate, if we move the button from the left to the right side and things like that to make the process easier. Additionally to that, we also have a so-called maturity model for feature flagging. And it starts actually below in the bottom in the so-called env swarm. So who of you has used environment variables as feature flags? No, a few. I'm surprised, not that many. You can be honest, nobody will be blaming you. So where you're simply using environment variables, it's not really feature flagging because you need to redeploy, so you restart your service that it's actually taking effect. Then, on the next level of the maturity model, we have this kind of dynamic configuration where we have a single place to flip the feature flags for our operations, like those toggles for a certain payment provider and things like that. On the third level is dynamic evaluation. Here it gets really interested, where we have per user, per segment, or per tenant targeting. So we can allow personalization or progressive rollouts and really taking a look how we can do context-based evaluations. And on top of that, the last level of the feature flag maturity model is actually the operationalized feature flags. There we have it as a core part of our software delivery lifecycle. We know the ownership, we have clean policies, we have observability and see where feature flags are evaluated, and we have proper audit trails. And this is actually where OpenFeature comes into play. Every time there's an image, I need to drink something. Else I'm too fast. So, OpenFeature is a vendor-agnostic, community-driven standard for feature flagging. We are a cloud-native computing foundation incubating project. I'm pretty proud about the history of OpenFeature because we learned about the problems we had with OpenTelemetry, etc., of multiple projects getting merged together, and a new one is getting generated and things like that. And OpenFeature was generated in the concept of an open source project directly with the CNCF. So in May 2022, we started talking about OpenFeature. In June 2022, we were already part of the CNCF. And in November 23, we got into the incubating stage, actually. And today, we're a highly collaborative, vendor-neutral system where a lot of parties are working together to make actually the best kind of sorry, I'm having a hard time with the words today, to get the best kind of thing for everybody out in the world. So, the reason why we wanted to to create OpenFeature is simple. I used to work at Dynatrace, and in that kind of sense, it was observability. A lot of people had different kind of feature flagging systems, implementing it in a different kind of way, and it was hard to observe. And a lot of people actually want to generate insights for their users. We want to know when a feature flag affected the performance of a system. And that's so hard to do when everybody's doing their own, cooking their own recipes, doing their own implementations. And there were also a lot of shared pain around in the community, how to migrate from one to another. And that was simply the idea, hey, let's start doing this, and let's start creating OpenFeature, which is an open specification that provides a vendor-agnostic, community-driven API. And this works for every kind of feature flag management tool you like. Is it your own? Is it a vendor? You can decide whatever you want. How does this look like? In general, we have your application. Do we see that? No. OK, then let's take the mouse. You have your application which is actually only interacting with the evaluation API, and that's the core concept we will be talking about now. And this evaluation API will then communicate with a provider, which is the abstraction to your feature flag management tool. And how does this look like from a Java perspective? So in the end, we are always using a singleton because it's easy to instrument a singleton everywhere in your code base. You do not need to care about dependency injection or anything like that. The OpenFeature API is always a singleton. You set a provider there, and after that, you can grab a client. With this client, you can do already feature flag evaluations. So this part at the beginning is actually the initialization. The rest you can do everywhere within your code, getting the client. And then we're doing an evaluation. In this case, we are fetching, for example, the feature flag named v2 enabled. And the cool part about OpenFeature is we are polyglot, so you can find us in multiple kind of language. That was Java. Node.js looks pretty much the same. Golang looks also the same. So we have multiple SDKs in multiple languages, which are actually actively used already by a lot of companies, which makes the life even easier. Additionally to that, for the evaluation API, we do support multiple types of feature flags. A lot of people think about a feature flag of just on-off toggles, booleans. Yes, that's our bread and butter. We support that. But we also have strings in there, so you can have variant names, region codes, labels, or anything you can imagine as a string. We have numeric values. In Java, it's int and double. In Python, it's int and float. In JavaScript, it's just number, so you can store numeric values there. Or even objects, so people use that, for example, for thresholds, for upper and lower bounds. Important to note also, you have seen that maybe, we had this second attribute within our feature flag evaluation call. And this is actually our fallback, and it's not optional, because we decided, architectural-wise, that if we throw any kind of error, if your provider is not accessible, or your feature flag management system is down, or anything like that, we will return this default value. And it's really, really important to think about what you're putting there, because in this case of an error, this will be the value you will get getting back for your code. So, to summarize, this was the core concept, and the most important concept of OpenFeature is actually the evaluation API, because that's what developers interact with. It's one API available in many languages, and we never break your code. So that brings me to the feature flagging iceberg, because a lot of people think feature flagging is quite easy. When you take a look at it on the surface, it's just flag evaluations, glorified if conditionals. But on the bottom, there are a lot of things piling up. So a Boolean toggle is easy. It's just if flag and then do the new thing. And that's not that complicated. But when you take a look deeper, you want to prevent vendor login. You want to have dynamic attributes there. You want to care about stale and obsolete flags. There are observability gaps you want to think about, and way, way more stuff like audit trails, etc. What you need all to take care of, and it's just getting, there will be more and more topics you will uncover, which you need to take a look at. So first, we will take a look at the vendor login problem, basically, and that's about homegrown solution and specific SDKs that basically trap you within your software code. So on the one hand, we have the homegrown, where you're basically your own vendor. As we talked about already, those glorified conditionals are really easy to implement. You have really fast wins, and you will see fast progress at the beginning. But over the time, the complexity creeps in. And at the end, you most likely are building your own platform with an own API, an own UI, and observability on top of that, which gets really, really complicated. Of course, you can switch to a vendor, and then you have suddenly this relief where it's easier because all the complex stuff is handled by the vendor, but you still have those SDKs, those vendor-specific SDKs. So if you want to migrate away from them, you have this migration pain, which makes it really, really hard to get out of. And that's where the concept of providers comes into play. So when you take a look at, like before, we already had the evaluation API, which is our core interaction with OpenFeature. We can plug into the SDK any kind of provider which communicates with our feature flag source. That allows us to be really, really flexible. When we take a look at the source code, we had at the beginning this in-memory provider, and we can simply swap it out to a FlagD provider, which is our cloud-native reference implementation. At one place, the rest of the code is never changing. You can even put in there, for example, a launch darkly provider or a split provider. There are around 130 different kind of providers out there which you can currently use from different kind of vendors. Or, if you like that, you can put in even a multi-provider, which allows you to migrate from one to another provider with different kind of strategies. So, the providers, to summarize the providers as our second concept, which I wanted to show you, is basically the vendor-agnostic part. We allow you to swap out your provider without rewriting most of your evaluation logic, and you can mix the sources whenever you need it. It's just a fun little concept which we have stolen basically from OpenTelemetry in some kind of way. So, the second problem, and that's the problem I'm most happy about and I'm most hyped about, is actually that static flags aren't enough. Sometimes we want to put in rule sets. We want to do a little bit of dynamic evaluation. So that's the third part of the feature flag maturity model, actually. And we want to do that for multiple reasons. On the one side, we already covered a few of those. It was the A/B testing, where we want to ensure that maybe we can change the conversion rate by moving buttons around or by changing the UI a little bit. Quality assurance, I mean, a lot of people are basically saying that their staging and production system are the same, but usually on the production system, you have way better alerts and operation is reacting if a request is getting slower. So you could theoretically first test it in production for just your quality assurance, then premium users or dog fooding, or even compliance, for example, for regional constraints. So when you have a service running in multiple countries and you suddenly realize this is illegal in Germany, you would add this in your code path. And when you realize a week later it's also illegal for Austria, you would need to change your code. But with OpenFeature, you can delegate this to a third-party system and do basically that in the feature flag evaluation. So you do not need to change your code. You just do it in the feature flag rules. To take a look at this, we need to take a look at feature flag configuration in general. And each provider, this is a disclaimer, each provider has their different way of defining feature flags. This is FlagD. This is our cloud-native reference implementation. That's open source. You can use that. But we are using just a simple JSON structure for writing feature flags. So you see here, for example, this is the name of our V2 enabled flag. It has two variants. That's also important. So variants in the Boolean sense does not make sense with true and false to give them name. But when you think about numbers, etc., it's really important to give them more context. And when you put a name to a number, it's easier to understand also for your operational people. And here we have the targeting rule. So when the user email ends with @domain.com, we return the on variant and else the off variant. It looks quite easy to understand. The only thing we need to do is somehow to provide the so-called evaluation context to it. And that's the third concept I want to talk about. And this is actually quite easy. In Java, it's a hash map, which we're wrapping into an object, and we can provide as a third parameter to the feature flag evaluation. Okay. That's easy now. We can do that for user targeting, and that's quite powerful. But think about what else we can do that. So we have seen user targeting, but what about other properties in the evaluation context? And here comes the cool part, which I like the most. We can put in there operational context. We can put in there our hyperscalers, our Java version, app information, platform information. And suddenly we get a rich tool set, actually, to reduce the blast radius of bugs. So we can now say, hey, we are only targeting staging clusters or Android versions with that kind of Android version has a problem. We disable this feature for just this Android version. This allows us to get out of this, our normal hotfix path, basically. You can actually analyze how many users are actually affected, deactivate it for them, if it's not as critical, and use the normal software delivery lifecycle than doing a hotfix branch and things like that. But adding this as a third parameter all the time and putting this context into place all the time as this third parameter during the evaluation is quite tedious. And that's why we have also the possibility to do it a little bit different. So for example, we can actually set it on the instance directly. So during initialization of our application, we can set some kind of evaluation context from environment variable, which region we are in, etc. We can do it during the transaction, for example, with an interceptor to set the request ID or user information, language information. We can also set it just per client. OpenFeature has the concept of multiple clients, which can have multiple providers. So you can set it just for one client, or as we had it already there during the invocation. Important to note there, we also have a merge order. So the API will be overwritten by the transaction, it will be overwritten by the client, and then overwritten by the invocation. So you can put the same attributes on multiple levels in there, but you can override it always on the stage closer to the invocation. And that brings me also to the next part, actually, when it comes to this dynamic evaluation attributes. We also talked about canary rollouts and how we can do rollouts basically for a certain amount of users, bucketing them. And we have there a problem, because how do you ensure that it's always targeting the same user? you have this deterministic problem where you do not want to get the user into this flaky kind of process that the button is jumping around between each request from one point to the other, or that the colors are changing from red to blue all the time. That's not a rollout, that's actually chaos. And we also thought about that. So we have the concept of the targeting key within OpenFeature, which you can easily set to something you define. So you can set it to random value if you want to have pure randomness. You can set it to a device ID, to a user ID, to a session ID. With that, it stays, the evaluation stays always the same when you do some kind of bucketing logic, like percentage-based rollouts. So the evaluation context is actually the part which allows us dynamic evaluation. We can put in any kind of information we like and forward it basically to the evaluation API. It offers deterministic targeting, and it can be used to reduce the blast radius of our bugs, which is, in my opinion, the most powerful tool. Sorry. So, and that brings me to the third problem which we want to tackle, and that's obsolete feature flags. So, obsolete feature flags is something which is hard to define. So, as obsolete feature flags, we define flags which are never changing its value at all, or which never get evaluated at all. Those are two sides. But if you have been careful at the beginning, we also talked about operational toggles and permission toggles, which are in our code base for ages, and they sometimes do not get evaluated to the same value all the time. So you need to be careful what you are choosing there. So what kind of flag you're really talking about here. When we take a look what happens in real organizations, so I had the benefit of working at Dynatrace, and we had thousands of flags accumulated in our old feature flag system, where hundreds of those have never been evaluated in months, and some of those go back for years. The oldest one is actually a temporary feature flag back out of the year 2018, and it was still in the system and some used somewhere. The problem we had there was basically we never knew, from an operational perspective, you do not know where this flag is used, in which repository is it. In a microservice architecture with 100 repositories, you need to do a code search. Is it somewhere used? Is it and not even then you get the basic feedback out of it. And it means that you have either dead code somewhere, code which never gets executed, but you still need to test, which means technical debt on the one side. Maybe the code is already removed, but you still have the feature flag. Then it's a technical debt on your operational side, because you still need to care about this feature flag when you take a look at how the software is behaving in production. And this just adds hidden complexity. And we want to get rid of that. And the big question everybody is asking, but when is it safe to remove such a flag? OpenFeature also does not answer this question, I'm honest here. But we give you the tools at least to observe flag evaluation, so you can make an educated guess about feature flags and what they are doing. For that, we need to take a look at the feature flag evaluation lifecycle in OpenFeature. Because in the flag evaluation lifecycle, we have 4 stages in which you can hook into. It's the before stage, the after stage, the error stage, and the final stage. I think they are pretty self-explanatory. And the cool part about the stages and the hooks is that you can simply hook into that really, again, at multiple levels. So you can do this during an invocation, which is really not the nicest way or a little bit tedious. You can do it per client, or you even can do it again on the whole OpenFeature instance. Why I'm showing you this is actually we are also providing you an OpenTelemetry hook out of the box. So you get observability. You get information on your traces, like what feature flag was evaluated during this request, to which value, which variant, which provider was used. And when you have errors, you get error details. Additionally, complementary, you also get metrics, like total evaluation calls, success and error counts, active evaluation counter. Those hooks are available for most of our languages. Sometimes they are better implemented. Java is always really good. Others are not that far, do not have the full feature set by now, so Python needs a little bit of work. But you get most of the insights there already. And the cool part is, this is not just something we came up with, it's part of the OpenTelemetry semantic convention. That means it's standardized how your feature flag properties and attributes are within your traces and metrics. Other use cases, for example, for those hooks are, for example, logging. So we do not log on the hot path because it's still some kind of time there's still some kind of computation time for logging which gets lost. So if you want to use logging and want to have more logging output, basically you need to add a logging hook to get more information. If you want to do alerting, for example, if a feature flag is evaluated to a certain value, which is for you a dangerous signal, you can utilize the hooks for that. Or you can do, for example, context enrichment, where you talk, for example, to a third-party system, which allows you to enrich the context further with user entitlement, any kind of other information you would love to have there. So the hooks actually allow you to observe, enhance, and extend an existing provider actually without forking it. That's also an important part. So usually when you use any kind of provider and you want to have further functionality, you can use hooks for that. They allow you they allow you to addition of arbitrary behavior at well-defined points of the feature flag evaluation lifecycle. I got lost here, I'm sorry. So, to summarize this a little bit, I'm too fast, but I have slides prepared afterwards. So, what are the key takeaways I have shown you now? We had 3 problems. I showed you 4 concepts for 1 standard. On the one hand, we have the evaluation API. That's, from a developer perspective, the thing you need to know when you want to work with feature flags. It's just a simple call with the client how you can do feature flag evaluations. It's also important that we never break your code and that we have this fallback value in there. I showed you how you can work against the vendor login problem with the providers. You can have a vendor, you can use an official OpenFeature provider, or you can even write your own provider for your own feature flag management system. We talked about the problem of dynamic evaluation and how the evaluation context allows you to do user-based evaluation, but also allows you to reduce the blast radius of bugs, for example. And we took a look at obsolete feature flags and utilized this to show you the concept of hooks. And together with OpenTelemetry, how observability data actually lets you do a little bit of an educated guess on which feature flag I actually use to which value, etc. But we did not cover all the concept of OpenFeature, and that's the interesting part also. We also have the concept of tracking in OpenFeature, which allows you to actually do verifications of experiments. So you can add a tracking call to see if an experiment actually correlates with a value actually. So that you, for example, if you put somebody in a bucket based on a targeting key, did they check out with a higher value when you recommended, so when you showed them a banner, for example, for reduce, if they buy something with a value more than 100 euros, that they get a reduced, that they do not have delivery costs, if that banner actually did the thing you want to do. Or you can use events, for example. We also have the concept of events. So you can react to state changes in OpenFeature, which is also interesting, because a lot of systems nowadays do not allow you direct access anymore to your nodes, etc. So people in certain companies use this, for example, for cache clearing. They use the feature flag, and when the configuration changed, they cleared the cache for certain users. It's abusing of the system in a certain way, but it works and gives you more flexibility and access. So generally, we love to say that OpenFeature brings confidence to everyone within the software delivery lifecycle. And I hope I could show that a little bit. It's not just about developers making it a little bit easier to switch out your provider. It's not about testing, A/B testing, and things like dog fooding or stuff like that. And it's not. It also offers, for example, your PM a little bit more tools and say, hey, I test this feature before I set it live. It gives you this little bit of flexibility. Important, why I'm talking about OpenFeature is more like I want people to join us on this kind of adventure. For us, we are a community, and that's really important. We only can grow with your insights, with your experiments, and all the kind of things you are missing, basically, in this kind of context. So feel free to join us on the official CNCF Slack, join us on GitHub, or even join us in our community meetings. We are here. We like to talk to you. We like to hear from you, and we like to grow with your problems. A few of you already heard about OpenFeature at the beginning. The cool part is OpenFeature is actually quite well received in the tech industry out there. So a lot of companies are actively using OpenFeature already. You just do not hear about that. So Booking.com is using it heavily internally. Spotify, their Confidence by Spotify, their platform, is based on OpenFeature. Dynatrace is using it internally. eBay switched, I think, 2 years ago even to OpenFeature as one of the first adopters. So there's already a really wide spread of this system used by a lot of bigger companies out there. And maybe sometimes it's your company standing there. That would be really cool. What I really like you to do after this talk, so my really call to action here is try it out. Experiment with it. See how it works for you. There is openfeature.dev where all the providers are documented, all the SDKs. You find a really good starting point, even tutorials and things like that. There's FlagD, which is our cloud-native reference implementation. It's open source. You can run it as a sidecar. You can even only use a file mode, basically, to experiment with that, which is really, really interesting and fun to see. Especially the FlagD playground, where you can play around with targeting rules. So you can do, for example, user-based rollouts. You can take a look at how you do this with emails, what context you need to provide, and things like that. And there's also this fun with Flex demo I created with multiple kind of technologies and multiple kind of languages with OpenTelemetry where you can take a look at. I'm way too fast. I'm sorry for that. So I say thank you now, but I have more topics there, and I think we will continue because there's still 18 minutes left. So yeah, here's the thing. So we talked about OpenFeature, and we talked about how OpenFeature is actually how you utilize this with this nice little API calls where you have the string in there and the fallback value. And we realized that this is actually a really, really, really brittle API by design. Because when we take a look at this call, and this would be our normal call, somebody could make a typo in the flag key name. Somebody could implement different fallbacks. One time it's true, one time it's false. Or somebody could use the wrong return type. When it's a Boolean, they expect a string or something like that. And that's really brittle by design, actually. And what we came up with is a tool, which is currently in an experimental phase, which allows you to describe a flag manifest, basically. We do not care about the values. We only care about the default value. We care about the name and about the description. And with this little manifest, you can generate type-safe accessors, actually, for your source code. So you do not need to know the names anymore. You have actually tooling around that. So you do not have these typos anymore. You do not have this type mismatch anymore. And there's one clear default throughout your whole code base. But this is still experimental. It works really well in Java. It works really well in TypeScript. And I think in Go, it's also working really, really well. And we are adding more and more languages. But it's still an experimental feature. So yeah, although feedback and contributions are highly welcome to let us know if what is working and what is not working. And the second part I prepared here is actually OFREP, the OpenFeature Remote Evaluation Protocol. So when you take a look at evaluations, feature flag evaluations, and we've seen this targeting rule can actually contain a lot of business critical information. Which users are premium users, what kind of features are available, and things like that. And what kind of other variants are available for a feature. And we want to keep those rules off the client. We do not want to ship them to a JavaScript frontend. We do not want to ship them to an Android device because people can inspect those and can take a look at them. And we want to be just sure that the people do not see this business critical information. And that's why we generated the OpenFeature Remote Evaluation Protocol. So these are simple REST endpoints you can target. And then you just get back basically you provide the context, like a targeting key, the tenant, and the region. And the only thing you're getting back is a key, a value, a variant, and the reason why it happened. This allows you to be way more flexible when it comes to your front-end stack and moves away this problem with business critical information from the user domain. Cool, I'm still too fast. I'm so sorry, that's now the last topic I had in there. I'm really, really sorry that I was talking so fast and that I didn't explain a lot. So I hope you enjoyed this presentation. I'm really, really sorry for being that fast. I can talk hours about that, and I have more topics if you like to talk about it. Thank you, and if you have any kind of questions, feel free to reach out. Or ask now, basically. No? Wait a second. Yeah. Cool. Yes?
Sorry, just a very basic question. But so it's just a dependency, right? OpenFeature.
Yes.
You need to deploy it in a separate Docker as well to store it, or how does that?
It depends on what kind of provider you're using. There are multiple providers out there. So, for example, FlagD, our reference implementation, also supports theoretically a file mode, or it supports a file mode, but we do not recommend that. So you can point it, for example, to a REST endpoint to fetch the configuration from. Our reference implementation is actually utilizing FlagD in a way that it supports two kind of different communication methods also. So you can run it so stepping is a little bit back. I'm sorry, I'm a little bit nervous. So we utilize FlagD basically as a proxy in the middle, because when you have a lot of services and a lot of pods fetching your feature flag configuration from one kind of endpoint, you're starting to DDoS yourself basically with a lot of requests, specifically when you want to compute them out of a database or things like that. Of course, you could do caching to make it more efficient, but in the end, we wrote FlagD as a some kind of relay proxy in the middle, where you could have also the possibility, though, to do evaluation on the FlagD. So if you have, for example, systems which you do not trust, you can do remote evaluation, and each call is going to FlagD, and FlagD evaluates and gives you the value back in a certain way. But what we're also supporting it for for systems where we need more performance is the so-called in-process evaluation, where we have all the evaluation logic within our Java process, basically, and we are only getting the updates when the flag configuration changes. We get an update, and the new configuration lives within the Java process, and you're doing the evaluation there. Exactly, and the benefit of utilizing FlagD there is that you can configure FlagD to fetch from multiple sources. So FlagD is really powerful. It could be an S3 bucket, it could be a Git repository, and depending on where you store it, you need to either poll it or you get event updates automatically. So when you get those event updates, it will populate those updates into your system automatically without you actually additionally polling from your service all the time. No. Yeah?
Did I understand it correctly that when we do feature flagging like ad hoc in our company now, we sometimes use customer properties or user properties, so we use like our security contract which checks like permissions within the system. Did I understand it correctly that you could use like the FlagD format to query other parts of the system to look at permissions in a unified way that would be then defined on the flag how it should look it up?
You could utilize a hook for that, basically. So you can write a hook, which is talking to your third-party system, fetching this kind of information, and enriching your evaluation context. And the targeting rule is then part of your flag, but you need to enrich the context in a certain way, and that's a dynamic attribute which you can do in a before hook. You can do the Yes. I take the back.
You mentioned the flag manifest type safety feature is experimental. Is that behind the feature flag itself, or is that?
No, it's just a CLI, so it's an npm module actually, which you can use to generate it. So. There is a discussion actually about that, because I think somebody wanted to write his thesis about this, his PhD thesis. So there is a discussion going on how you can consistently ensure that feature flags are the same definitely through one system to another, because you also have, there are a lot of problems with that, because theoretically, even if they have the same feature flag set, when a request is happening on a one system, you can get an update, and then suddenly the feature flags are not matching. That's really a hard problem, where I'm not sure if we have a dedicated solution by now, but there's somebody who put a lot of effort into that already and thought about this. So there is on GitHub, you can find the discussion around that, and you can even reach out to that person, most likely. Other questions? It looks okay. I'm sorry that I was that fast. The last time I was used 1 hour for the whole presentation without the bonus material. I'm really sorry. If you like, there are some stickers on the projector, also from OpenFeature, etc. Please really feel free to reach out if you have questions, if you want to take a look at OpenFeature, if you're unsure what to do or how to do it. I'm more than happy to help people adopt OpenFeature and feature flagging in general. Thank you very much for your time.